Welcome. This is workshop number 1, piston head analysis. This time we're going to become familiar with all the steps necessary to create a very simple model, analyze it, and post-process the results from its analysis using MCS Patron and MCS Nastran. We're going to determine if the stress in this typical piston model is low enough for the material to be in the linear elastic region. We have the modulus of elasticity and the position ratio and the pressure on piston. So now I'm going to explain you what we need to do. First of all, we need to do create a new database. It's going to be called Piston. Okay. Now after that, you will need to import the head of the piston, import the model geometry. So in order to do so, you need to go to menu, file, import, and here you must see the piston file that is .xmt, but in my case I don't know why I can't find the piston file because I already searched for it in my PC. So if I look for piston here, I must find, or that what I supposed is to find a piston.xmt file, but I already look in my PC and I don't have any file of that type. So what I'm going to do is only explain you the steps that you need to do in order to analyze it if you do have the piston xmt file. So I'm also going to look for any xmt file in my PC, so you can see that I don't have the piston file. Now I already have all my xmt files, and as you can see I don't have any file named piston. So yes, now I'm going to continue to explain you how to do it if you do have the piston xmt file. The file should look like this piston. Then when you have this file, you're going to create a mesh. It's going to be in create mesh solid TED mesh and TED4, because TED10 I can't use it because I have a student license of Patron and I need to have the complete license. Input list, you're going to select all these piston, all the solid one. You're going to take off automatic calculation, and in value you're going to write 0.5 and you're going to click apply. After you have done this, you're going under loads displacement constraint, and in new set name you're going to write fixed. Input data translations 000. Okay, select application region. Well, in here you're going to select this this surface, and the other surface that's on the back. You're going to have to rotate the cylinder in order to select it, and you have to go on. Well, you will have to click under select geometry entities, then on the surface or face icon, select both pinhole faces and click add, and click OK and click apply. So you will select surface or face, and in here you're going to select the two faces that I already mentioned you, and After that, you're going to click add them, OK, and apply. We're going to create a pressure. Object pressure. It's going to be called piston pressure. Input data 1200. Select application region. Here you will need to go to the PDF and you will see that the pressure is going to be selected in the top face of the piston. That's this zone. So you will do click in select solid faces, select the top face of the piston, add, OK, and apply. Now your file must look like this, with the pressure and the displacements here in the holes. Now we're going to create the properties of the material. Create isotropic. The material name is going to be steel. Input properties, elastic modulus is 30 e to the 6th. Position radio 0.3, OK, and apply. And now you're going to create a 3D solid in properties, 3D properties, solid. Property set name is going to be piston. Input properties. In material property name, you're going to click on the picture and select steel. OK, select application region. In select members, you're going to select all the solid, all the piston with this box with the left click. You're going to click add, OK, and apply. We're going to check that the loads are added and selected. Here in load cases, you click in create load case. In default, you click and you will see that the displacement and pressure force, column fix and piston pressure respectively are selected and ready to make the analysis. To do the analysis, we click in the analysis entire model. Job name piston. In solution tab, we need to make sure that linear static is selected. Solution parameters and results output format should indicate that XDB and print are also on and selected. So we go back and click apply to run the analysis. I won't do it because I don't have the file in here. After you run it here in Patron, you must run it in Astron. You're going to search in Astron file and look for your BDF file in order to open it in here and run it in Astron. And after you run it in Astron, you're going to attach your XDB file, analysis XDB. Select results file. In here, you must see that an XDB file named Piston is shown, and you will click that file, click OK, and you're going to click apply. And when you do that, all the analyses are already made. So you only need to go to the results tab. So these are the final results after you already put all the criteria and options to see it this way. So now I'm going to explain you how to get into this. First thing you need to do is go to Home tab, click on Plot Erase, and you're going to click Erase in Geometry, and click OK. Then you're going to Results, Create. you're going to click on quick plot. Here you're going to select the only file that is already analyzed. Here you're going to select stress tensor, and here displacement transitional. And also down here you're going to be sure that you select von Mises stress analysis, like this. Plot erase, erase geometry, okay, create quick plot, stress tensor, displacement transitional. Select the formation result respectively. Von Mises, apply. So you should see this in your computer, in your screen. Okay. Now you're going to modify the deformation attributes. You're going to click on the deform attributes icon, uncheck show on the form and show title. Click apply, then you're going to click on the plot erase icon, click on erase under geometry and click OK. So we're going to click on the deform attributes icon first. Here. Then we're going to uncheck show on the form and show title. Show on the form and show title. Then you're going to click apply. Then we're going to click on the plot erase icon. You're going to click apply in here. Then we're going back to home. Plot erase icon. And we're going to erase geometry again. Erase. Okay. And you already did apply in here. So now we're going to modify the fringe attributes. You're going to click on the fringe attributes icon, set display to element edges, and check show title and click on apply. Here we are, then display element edges and check show title, and then you're going to click apply. And after that, you must have this piston with this illustrated like this way. And I hope this video was helpful for you, and I will see you the next time.